There is a difference, yes. If it's an ECM motor board, it's not the same as this one. That's the problem. If you try to get the wrong OEM part, it won't work with the original board. I know, I hate that. Because sometimes they don't have it in stock. And what are you doing? You're calling around and you can't get it. And you're pretty much stuck. I know. I've been there, guys.
New furnace.
Well, that's a possibility. Offered to them, yeah.
After $1,000 and a month of waiting.
I agree. I agree. But I think that what's going to happen is the distributors are going to step up distribution of these parts once they're the only parts in the market for all the new stuff. So that's one good thing. This, as you can see, is in off and the fan is on. One of the things that I did about this, I'm gonna walk through what I did on the wiring of this so you guys understand. This pigtail that comes in right here, it's just a regular standard pigtail you put on any furnace, right? You guys have seen it, right? Great pigtail, right?
Where's it going to?
It's going right to the L1 and the common of the board. L1 and common. If you look at the wiring diagram, that's where the pigtail is connected in a normal furnace.
Well, where's it going, to the motor? Or on the
Well,
other,
I'm gonna walk you through. Well, typically you got a door switch, but in this case you don't have a door switch, guys. All right. So I hooked up to L1 and common. Here's our common, right here. See, right here, and here's our power. This is the gray right here. Then what I did was I took this wire right here, and I wired it all the way up to my transformer, my control transformer. So my 115 volts is going up to my control transformer, just like in a standard furnace. And then I'm coming with 24 volts out, coming down through here and through here, and I'm wiring the 24 volts to this other side of this board.
Am I replacing the transformer with it?
No.
Or no, that's just
I just grabbed parts and threw them together.
Okay. That's just a standard transformer.
This is a standard transformer and standard thermostat, a standard board.
Okay, so that's like normal, just replacing the motor.
That's really, I wanted you to see how you can take that ECM motor and retrofit that into a standard furnace, a non-ECM furnace.
It's a way to help the customer get more airflow if they're having
Yes,
issues.
these motors are stronger. They do push a lot more air.
20% of what you say.
Yeah, they're 20% more efficient. Yes, they are. So what I did was these two wires here go to where the speed selector on the board is. These are the relays that the old motor used to turn on and turn off with. You know, when the air conditioning came on, when the heat came on. So these are actually now high voltage communication wires. The motor uses it for communication.
So it's different, it's not necessarily power.
It's not power. What they're doing is they've got the power right here.
Yeah.
This white and black is tied to the same place as my pigtail. So it's got 115 volts to this motor all the time. At all time. I want to stress that. Just because it's not running doesn't mean there's not 115 volts to that motor, guys. All right? They still will go poof if you touch it in the wrong place.
Don't let the smoke
Okay?
out.
So, don't let the smoke out. These are communication wires, and they're used to communicate to the motor by using this original board. Then it's got 4 wires down here, which are 24 volt communicating wires, and you just put them on where the thermostat wire goes. So what happens is, if I take my thermostat and I put it to cool like this, and the cool just came on, the motor will now come on in high. And it comes on slowly, but it walks up. It's not boom on, it ramps up.
Kind of like
Are those 4 wires with blue color?
They are not. You have to look at the diagram. They are not typical colors. I'm glad you pointed that out, because at first I thought that they were, and I put it together wrong. But they actually have the high speed on orange, and the second to high speed on yellow. Yes.
The reason on the ECM motor, the reason when they start up slow and develop the speed, is it for the noise reason?
No, it's actually a frequency adjustment, because what they're doing is they're adjusting that frequency, and they started off so that the current draw is not slammed in. It's not inrush current. And so they go 1, 2, 3, 4. So they develop speed slowly because that's actually more efficient than just slam on, slam off.
That's why it's so quiet.
And that's why it's so quiet, right? That's right. So if you look over at this, I've got right here on this, can you see that? It's a watt meter. Is it reading watts there, Toss?
Yeah, well,
Okay.
39, 40.
It's actually measuring the watts that are being drawn by that motor. If I take this thermostat and I turn the temperature up so that the air conditioning wants to turn off, guess what happens? It starts very slowly ramping that motor down. And the watt, you can't tell at first, but if you look at the watt gauge is going down. It's going down, drawing less current because it's walking down in stages, in digital stages. And it's doing that slowly because it's actually wringing all the extra cooling out of your evaporator coil for free. It's free cooling. The outdoor units shut off, but there's still, that coil is still cold. So it's pushing more air over that coil to harvest that extra cold that's in that coil. Yes, sir.
Is there an age on how old of a furnace can we adapt?
No. If you've got one of these electronic boards, the answer is if it's not an electronic board, yeah, it's going to be tough. Because it was designed for furnaces that have electronic boards like this. So, you know what? The truth is, we probably could figure out how to do it with just electrics and not electronics, but it would be harder. And the wiring kit that comes with it, the diagrams, are assuming that you've got this kind of standard board. Does that make sense?
Yeah.
Okay, now I'm going to, you remember what that wattage was on full? I think it was just under 300 watts.
400 to 390.
Okay, if I took the fan to on here, what I'm going to do is going to turn on again, and it's not going to pull as many watts because it's on a different speed. You can't hear the difference, but the watt meter tells you it's a different speed because it's drawing less wattage.
275.
Yeah, so it's less. You see that? There's two different. If I put it on heat and I turn the heat on, it does the same thing. It comes on a slower speed, and you can tell by that watt meter that it's pulling fewer watts. That makes sense?
Yeah.
This took Hector and I about 4 hours to put together from scrap parts he had. Now, he did build this. He did have this built. But everything else was just off-the-shelf stuff, guys. This is doable by anybody here. This is not intimidating. All right? Is there any questions at all?
No, right here you don't have the pins from the other.
I don't.
Oh, yeah.
He's right. I don't have this Molex plug stuck in here. And that's because a couple of things. I don't have a furnace. And that's what most of these go through. And this blue wire that's on this is my limit. That goes through all my limit switches.
But when we install the motor, we still have the plug in there, right?
Yes, the plug, it would be in there.
Yeah.
Yeah. But I didn't install it because I don't have a furnace here.
Yeah.
And if you look, I've got a jumper wire in there because it wouldn't go without checking all those limits. So I jump it. There's no furnace, so it's not unsafe. But it's expecting to see those limit switches. Yes.
Is there a certain tonnage you could only use the ECM motors on?
The answer is no, because there's three different ones. There's a half, 3/4, and 1 horse. So obviously the 5-ton would be the 1 horse. And a 4-ton, probably a 3/4.
3/4, yeah.
And probably anything under like a 3 or something like that would be a half. I would always assume bigger, to be honest with you, because they'll draw less current. You can put a motor in